Welcome. Today we're going to be talking about Git and GitHub. You may have heard about GitHub. Software developers, designers, academics, data scientists, all kinds of people use GitHub to work on open source and sometimes closed source software and other kinds of projects together. It's a place where people collaboratively do work. They call themselves a social coding platform. It's important to distinguish GitHub from Git, however. They are related, but they're different. GitHub is the website. It's the platform where Git repositories are hosted. Git is a technology. It's a version control system. So it is the technology that underlies a lot of the project that happen on GitHub. We're going to talk about each of those, but first let's start with Git. Git is a version control system meant for tracking changes in computer files and coordinating work on those files among multiple people. It is primarily used as a source code management tool. However, it can also be used to keep track of any set of files, not just code. As a distributed revision control system, it's aimed at speed, data integrity, and support for distributed nonlinear workflows. That's a definition from Wikipedia. Here are a couple of things to keep in mind. First is that Git is a version control system. So at its heart, it's intended to help you keep track of changes in files. While those are coding-related files, they can also be all kinds of other things like images, legal documents, any kind of file, or we'll talk a little bit about different file types, but most kinds of files. The other thing to note is the definition says that it's a distributed revision control system. We're going to talk about what distributed means a little bit later on. And the last thing here is that Wikipedia says it supports nonlinear workflows. For many of you, this is going to be a new way of thinking about work. I really hope it enhances the way that you think about the work that you do or the work that you can do. We're going to discuss this in a moment as well. But for now, let's stick with the easier definition. Git is an open source program for tracking changes in text files, according to GitHub. Keeping track of versions is hard. That's why a lot of you might have seen this problem. Suppose you have a project and you keep updating that project, but you want to save all the past versions of it as well so that you can always go back to an older version or show someone the progression of the work. But this sort of renaming files over and over again and saving new copies of them is one, sort of a messy solution, and two, takes up a lot of space as well. So what is Git and what does it do? Well, Git is a distributed version control system, so it allows you to keep track of these changes. A Git project is known as a repository, and all it is a folder on your computer that contains all the files, just like a normal folder that you always use, but it has an additional little hidden folder inside that folder that's called a .git folder. And that folder will keep track of changes within files. These changes are sort of the base unit of a Git repository, and they're known as a commit. So a commit is a set of changes to either a file or a set of files. You can think of these commits as save points. So Git allows you to make save points at any point in time, and then you can revert back to any other save point or commit and start building off of that older version if you ever need to. Each commit also comes with something known as a commit message. So these keep track of what each save point meant. In the example here, you can see that we've added copy, then we fixed a typo, changed the background color, added the image. Each one of these are save points, and each save point comes with a message. These messages are usually written in present tense, and they're just a short description of what work has been done up until that point. So you can always go back and see when this change was made, what was that change? Well, it was the change in the background color. The other benefit of this is that it reads as a sort of a log, if you read it in chronological order, of how a project was built. So add copy, fix typo, change background color, add image. You can sort of observe the progression of that project. Git also allows you to compare changes to different save points, so different commits, and this is something known as Diff. The Diff feature is super useful. So let's suppose you were at this point in your project where you add the copy, and then a couple other things are done, and then finally there's this commit a couple days later that says add image. But let's say you stepped away from the project and you came back and you want to see all the things that changed between 2 days ago and now. The Diff feature allows you to look at two commits and just observe the differences in the files between those two commits. So while this progression tells us step by step what happened, we could also just say, hey, what's the difference between this first commit and this last commit? And then you can just use the Diff feature to see all the changes in the files. In software development, this is really good for tracking down how and when a bug was introduced, because Git keeps track of every single change, when it happened, who made it, that sort of thing. It's also really great to help you stay up to date with your project, to just see what's changed since you last worked on the project if you're working on something collaboratively. And it can also be really good for working as a team for code reviews, looking at quality and style of the code. I'm sure the diff feature is also useful in a lot of other contexts. We'll see a little bit later how it can be used in a legal document, for example. So these are known as diffs between any two commits. And I'm going to try to use commit more than save point, because that's the actual terminology. So hopefully you get used to the idea of a commit and a repository and diffs. So now we get to nonlinear workflows. Nonlinear workflows are one of the most powerful and I think novel tools that can really help you rethink the way that you work. Git enables you to use nonlinear workflows, which are known as branches. This means that you can have multiple versions of a project on the same folder at the same time, and you can toggle between these versions very easily. These versions are known as branches. You can split off a new branch of a project if you want to create a new feature or do some sort of experiment without really messing with the main branch. The main branch, it's now known as the main branch. It used to be known as the master branch. And when you're ready to incorporate those changes back into the main branch of the project, you can merge them back in. So here's an example of a workflow. Let's suppose that you're working on a project. The master branch, or the main branch, that's where the sort of production version of your code or the main version of the project is. At any point in time, you can split off and create a new branch, and you can work on that branch while other people are still working on the master branch. So if I was working on a website, for example, and I wanted to add a drop-down box, I might create a new branch called drop-down box. I'd write the code for the drop-down box, put that into a commit like you see here, and then I might ask somebody on the team to review that and merge it back into master, or at some point in the future, I can merge that change back into master. In the meantime, other people can continue other work on that project as well. One interesting thing about Git is that the base unit of Git, a commit, it operates at the line level, not at the file level. So you and a colleague can be editing the same file at the same time, as long as it's not the same line at the same time. And if you do happen to overlap and edit the same line, there's a way to resolve that conflict when you merge your feature branch back into the master branch. You can also create a new feature branch with multiple commits. So in this case, let's suppose at some point I decided that I wanted to add an entirely new page, and that page was going to be about kidney donations, for example. I might make a branch off of here and add some copy, add a color, modify the background, add an image, and at some point I can request that that entire branch be merged back into master. If I'm an admin on the project, I can do it myself. If not, someone else can do it. Within an organization, this is a really great workflow. There's also a way to do something somewhat similar with stakeholders outside your organization, where they can make a copy of your project, but they don't have the admin privileges to merge changes back into the main project. I hope you can really think about the nonlinear workflow and how you can apply it to your work as well. For me, it was a transformative experience. In this case, we talked about an example where we're building a website and we're adding a drop-down box or a new page, but you can think of it in a legal context as well. Let's suppose you're editing a legal document. You can think about a branch as like, I want to add this clause, and then I add it in and I ask my colleagues what they think, and they can merge it back in. You can think of it in a design context where you're doing a drawing and you want to test different, different parts of the drawing or the logo to see what it may look like, or different versions of a logo that you're designing. I personally use it in a news context all the time, where I'm editing text that's going to go on a web page that we're publishing. There are a lot of different uses of Git outside of just software development, and I think you can think about how you might be able to apply it in a policy context as well. More than anything else, I hope that using Git allows you to be fearless in making changes. Oftentimes we want to experiment with our software. We want to create a new feature. We want to mess around within a branch. You want to add a new variable to your model. All of these things can be done very easily using branches. So without messing with your main project, you can create a new branch and just be fearless. And if ultimately that doesn't work out, you can just scrap that branch and never use it again and go back to the main project at a stable state. Because Git always allows you to go back to a known good state, It's a really great way to allow you to do experimental work without worrying about messing up too much. Okay, so let's talk a little bit about Git versus GitHub. Git is a distributed version control system. It's a technology. So here we have an example of Dave and Lisa. They each have, let's suppose, a project that they're working on, a website maybe, and they have a folder on their computers that contains all the code for that website, and it also has, it's managed by Git, so it has a .git hidden folder inside it that manages all the changes. Git will allow Dave and Lisa to have a copy of that project. Each person will have a copy of all of the things in the project, as well as all of the changes that have happened to the project. So as they make changes, they can then synchronize those changes, so they can push their own changes to the other person's full project and vice versa. And this will allow them to keep themselves in sync. If you have a team of like 50 people, for example, theoretically, they could all individually push projects to one another. However, that would get a little bit messy. That's why we use platforms like GitHub. GitHub is a social coding platform where Git repositories are stored and where people can collaborate on projects. So GitHub is great for both collaboration within your organization and collaboration open source, or collaboration outside of your organization with stakeholders who might have an interest in keeping this software or project, whatever it may be, up to date, or who might have suggestions for changes to that project. You can use private GitHub repositories as well, but it's generally a good practice to default to open unless you have a good reason for keeping it closed. So here we have an example of Fred, Dave, and Lisa. Let's suppose they all work on the same team. They're pushing their projects to GitHub, they're pushing their repositories to GitHub, and then they're pulling from GitHub. So there's a sort of central source where you can push and pull the latest version of the changes, and the latest changes sort of live on the GitHub repository. But because Git is distributed, let's suppose GitHub went down, it would be very easy for one of these three people to just push a new version of the project to some other server somewhere else, and everyone could coordinate that way. They could coordinate internally, they could push to one another. There's a lot of ways to keep up to date. So you can see how the distributed nature of Git really gives it some resiliency and creates this, it really makes it a resilient platform. So this is different from older version control systems. A lot of older version control systems worked more like libraries, where you would select a file and check it out. And once you've checked that out, that file becomes locked to everyone else on your team. You make the changes you want to make, and then you check them back into the library where everyone else can see them. This requires one central node to be the library and keep track of which files are checked out and which files are not. GitHub doesn't work that way, or Git doesn't work that way. Git will just find all the changes that it can find, look at them in chronological order, synchronize them, and sort of allow you to work a little bit more seamlessly. And unlike those older platforms, once you're working on a file, that doesn't mean it's locked for everyone else. You can work on files at the same time. As long as you're not overlapping and working on the same lines, Git will automatically merge them. And even if you do end up working on the same lines, it'll just ask you like, hey, which line should be the main, the one that we keep? Like Fred and Dave both worked on line 16. Which one do you want? When you try to merge those projects back together. So it's really a great way for them to sort of work independently and yet collaboratively. So just to recap, Git is not GitHub. GitHub is the platform, Git is the technology, and Git repositories can be found on GitHub. So a couple of pieces of vocabulary before we move on to the next lesson. The basics: Git is a version control software. A repository is a project in Git. That's a folder containing the files, and also it has a hidden folder called the .git folder, which contains a structure that keeps track of all the changes to the files and all the different versions. Then there is the commit, which is the basic unit of a Git repository. It is a set of changes to a file or a set of files. A commit usually comes with an ID, a unique identifier, as well as a commit message that describes the change. When you're working with others, we're often working on GitHub, which is a place to host Git repositories and collaborate. And we use these terms local and remote. When we say local repository, we mean the version of the repository on my computer. So repository being the file and all the files and all the branches and all the changes in their version history, right? So the local repository is the version of that on my computer. The remote repository is the version of that stored somewhere else. In general, when we're talking about remote repositories, we're usually talking about GitHub, but it could be a remote repository anywhere else in any other platform. Like Bitbucket is a common competitor to GitHub. Amazon Web Services has something. A lot of companies internally have GitHub-like platforms. One's known as GitLab. And a remote repository could also be just a repository on someone else's computer that you're pushing to. So local is mine, remote is somewhere else. Okay, so now that we've talked a little bit about Git, let's talk about GitHub. As I mentioned before, Git is a version control system, it's a technology, and GitHub is a social coding platform. It's a website where Git repositories are stored. GitHub has a couple of uses. One is it's a great place for just storing and viewing your Git repositories. So I might think of it as a graphical user interface or a GUI on top of a Git repository to show you all the different versions in a more visually appealing way. It's also a great place for collaborating on projects within an organization. So different parts of an organization can have access to projects and you can collaborate within your organization. However, one of the more powerful features of Git and GitHub are that they allow for open source collaboration. And that means that you can collaborate with people outside your organization or even complete strangers, members of the public, or what have you. And these people can participate in your project. So they can suggest fixes, they can point out errors, they can start discussions, they can request features. So it's a really great way for you to interact with the public or members of other organizations to sort of collaboratively work on a software project. You can find other people's work on GitHub and you can make sure that you're not duplicating some software that already exists. So if you need a solution, you can always go to GitHub and see if somebody else has one. And if it suits your needs, you may be able to fork or copy it. Or if you can copy it and sort of modify it for your own organization's use, assuming that there is an open source license on it. We'll talk a little bit more about open source licenses later, and we'll have a lawyer come into the class who can probably answer questions better than I can about what different types of open source licenses allow for. But on GitHub, it's sort of convention to default to open unless you have some good reason otherwise to keep it closed or private within your organization. And it's a really great way to collaborate with other stakeholders on a project. It's also a great place for web hosting. There's a feature called Github Pages that allows you to host static websites on GitHub for free. And we'll get into some of these in a bit. I'm going to talk now about some more uses of GitHub. And at the end of the lesson, we'll talk about uses for GitHub outside of programming and coding. But right now, we're going to focus on the programming and coding uses. So again, it's a good place to store code along with all the revisions for that code and all the different versions of it. It's also a really great place to store data. What you're looking at here is 538's data repository. You can find it at data.538.com. This is just a nice user-friendly interface on top of our data repository. So for certain stories, in addition to the story, we will publish a data set. And so if you see this story here, underneath it says get the data on GitHub, and you can just click that and it takes you to our data repository, which contains a little bit of a dictionary, some information about that data, which stories it was used in, and then the data itself. And we have hosted a bunch of data sets on GitHub, and I know other news organizations do the same as well. It's also a place for discussion about data and code. So here you'll see in our data repository, this is the Issues tab, and this is where members of the public can come and say, hey, I have a suggestion on your repo structure, or there's some data missing in the burrito bracket, or, is the Oscars data available? They can ask us questions, they can interact with us. Sometimes they may even suggest fixes, and we'll get into that in a minute. It's a great place for open source collaboration. So what you're seeing here is members of the public who have actually come to 538's repository, found something that they think needs fixing, and instead of just asking us, they've recommended a fix for us. So if you look at this CSV, for example, this is, well, let's see what they're suggesting. They're suggesting a change in this one data point for Afghanistan. I'm not really sure why. They haven't done a good job of discussing that here, so I may not accept this request. But you can see how members of the public can come and say, hey, I think there's something wrong, or there's something I'd like to update, and they can actually recommend a fix. Here's one that I did. It's a library called Git Extras. And what I wanted to do was be able to download not just toggle between versions in Git, but download every single version of a Git repository into separate folders. I did for some audit purpose. I don't want to get too much into why I wanted this particular feature at a particular time. But what I did was I created a new command called git versions. So you say git versions file path, and it just downloads all the versions of the file path. And then you can see that the person who created git extras says, hey, do you have any use for this? And I told him I'm storing data, and it was updating daily in a Git repository. This lets me get all the versions of the file and observe how the data has changed. Then that person talks to the other developer of this repository, and that person said, in my opinion, it doesn't have a wide range of use, so I'll wait for other people who want to vote for it. By the way, Git status doesn't always display in English. It depends on the language setting of the machine. So I had written my code assuming that it always displayed in English, and because it didn't, that's one of the reasons why they don't want to accept this request. However, I still have a copy of this project with this additional feature for my own use. It just hasn't been merged back into the main project. GitHub is also a great place for collaboration within an organization. So here you can see these are our World Cup ratings, and these are all the different people within our organization who have at some point or another touched it. These are really old, so you'll notice the charts go back to 2015. This is somebody talking within one of our repositories at work. They said, we want to disable zooming by default on whatever this library is. And you can see here that people in our organization are sort of weighing in and saying, hey, I think we probably should, but I'd like to hear from other people first. And then those people will weigh in, and then we might decide to make that change or not make that change and then close it. In this case, they say the project manager says, okay, I'm convinced that allowing Zoom is a good idea, especially for accessibility reasons. I'm going to put a new issue in to fix the heading. So we just close this issue without actually disabling Zoom by default. It's also a really great place for finding other people who are working on the same things you are. So if you go into GitHub's search feature, for example, let's just say I go to github.com and I look up U.S. Forestry Services, I might be able to find another person who either works at the Forestry Service or has an interest in the Forestry Service or uses that data. So here, this is a Python API wrapper for the USDA's Forest Service, Forest Industry, and Analysis database. I don't know if this person works at the USDA Forest Service, but this might be a good person to connect with if I have questions about this data or if I want to use their software. It seems that this person is in Uzbekistan. Anyways, you can meet all kinds of cool people all over the world who are working on things similar to you are. And I think the more niche the thing you're searching for is, the more likely you are to sort of find a community of people that are working on those issues. So it's a great place to find sources or people with expertise in a particular data set. It's also a great place to find other digital tools like scrapers or file converters. So for example, let's say I wanted to convert SPSS POR format to a CSV format. Hey, there's somebody who's made an SPSS converter that converts POR or DTA formats to CSV files. This actually happens to be a colleague of mine who needed it for a project and then just open sourced that code. It's also a great place to find open source work and analysis. So if you're interested in a particular area of expertise, you might find code bases that are analyzing certain data sets. And it's also just a great portfolio of your technical work or technical learning. So you can pin certain repositories to the top of your GitHub. And so you'll see here's a media framing repository where I did some machine learning analysis on media text data, and that's something that I might want to show off, so I can just pin it to my repository. So it's a nice way to sort of show your technical learning, and I think a lot of hiring managers might be looking for a GitHub repository with at least, or a GitHub account with at least one repository maybe where you can sort of show off your ability to write clean code or comment your code or what have you. I wouldn't, just one note on a technical portfolio. I think it's pretty common to have a lot of sort of junk in your GitHub, to just have a lot of things that are just you experimenting and playing around with things. And so I wouldn't spend a ton of time trying to clean up your GitHub unless you really want to. But what I would do is make sure that like one or two repositories are sort of much cleaner and well documented and have all the things that you want to show off to an employer. And you can just pin those repositories here. You'll notice that I have 164 repositories. And a lot of them are legitimate projects, and other ones are just random one-off things. And I think that's usually okay, as long as it's clear where you want an employer to be looking when they first sort of come to your GitHub page. Okay, let's dive in. As I mentioned before, when we talk about a local repository, we're talking about the repository on my computer. When we talk about the remote repository, we're talking about a repository somewhere else, in our case, on GitHub. I'm going to use this as an example. This is the code for policy simple website repository. So github.com/code for policy/simple-website. And this is a website that I just had made to help show people during the shopping sessions for this course what the course is about. And so we just kind of explored GitHub a little bit. It's a very simple website. It's just got a little bit of information. And then if you click on this image, it has one piece of functionality, which is the image says, "Ouch, stop poking me." So it's a static website with one JavaScript element or one interactive element, which is the ability to click on the picture. So I'm going to depart a little bit from the markdown files that we've been using in this class. Everything that I discuss now is going to be visible in that markdown file, so you can go ahead and read it there if you want to get a refresher. But for our purposes, I'm just going to use this. I'm going to use this simple website repository to explore the different elements of a GitHub repo. Okay, so the first thing you'll notice in any GitHub repository is a README. This is in a format known as Markdown, but you can also have it in a text file, readme.txt. Anything labeled README will immediately render right here when you're inside any sort of project in GitHub. So these are the 4 files inside this repository, and you'll notice that readme.md is the same thing as what's rendered here. So if I click on readme.md, that is literally just this page, and GitHub is just rendering it very nicely here for me. It's whenever you find a new code base, it's always a good idea to look for the README or the documentation and glance at that first before you really dive in. It could give you a sense of what's going on in this repository. So here you see, this is a demo website. Index.html contains the contents of the website. Styles.css contains the styles, so backgrounds, colors, fonts, etc. Main.js contains the JavaScript code for the interactive elements of the site, i.e. clicking on the image to be able to interact with it. And you'll see these 3 different files. So I'm just going to glance at them really quickly so that you can take a look at what's inside. This is HTML. This is sort of the scaffolding of any website. Styles.css is the style sheets. So you'll see like background color, width, body color, padding, things like font will be in here. And then main.js is just a little bit of JavaScript. So there's a function in here that says, "Ouch, stop poking me." There's a definition for logo. So it grabs the logo, saves it in this variable called logo. And then logo.onClick equals say ouch. So when you click on the logo, it says ouch. So these are the 4 files within this repository, and collectively they make this one simple website. Now let's explore some of the features of Git and how they're visible within the GitHub repository. So the first thing you'll notice is there's something here called a commit log. So you'll see the latest commit ID, the date when that commit was made, and you can see when each file was last changed. So I'm going to click on this. And there are 9 commits here. Each one of these is one of the save points that we saw in the previous lecture. The commits all come with a commit ID, which is what you see here. This is actually a shortened version of the commit ID, which is a lot longer. It's this thing here. And then this is the commit message, so update styles.css. And if you read this in chronological order, you can get a sense of how this website was built. So I have initial commit, give the simple website some content, add colors and styles, make the logo yell when you poke at it, add comments to the code. So you can sort of see the development of the website over time. If you click on any of these commits, then you can actually see the details of that commit. So this is make the logo yell when you poke at it. And there's the commit ID again. This is the person who made the commit, the time it was made. And then if you scroll down, you can see exactly what changes were made on a line-by-line level to the project. So in this case, to make the logo yell when you poke it, I had to add this main.js file, which contained all these lines of code. And then I had to link that JavaScript file to the HTML file, which was the scaffolding for the website. So I added one line of code to this file, and I guess a blank line. And then I added all of these lines of code to a new file. Other commits might involve modifying or deleting lines of code. In this case, I just improved the README. And in some cases, in this one, for example, I removed background color is white, and I added background color is beige. So you'll notice that the lines that were removed are in red, and the lines that are added were in green. And so you can see exactly which changes constitute this commit, and you can even leave a little bit of a message saying like, hey, I think this red color, I can say, hey, I think beige looks much better than white. And the person who wrote this commit would get a notification and they could see that. Oh, it looks like they've added video support, which is cool. Okay. So now that we've looked at the commit log, the sort of history of changes, let's go to one particular file. Let's say the readme.md. There are a couple things I want to show you here when it comes to one particular file. The first is history. So we're going to look at history, raw, and blame. The history, it's just showing you the commits that are relevant to this particular file. So it's just like the commit log, but it's omitting any commits that don't touch the README file. The other thing here is raw. If you hit the raw button, that just shows you literally the text of the file without any sort of formatting. And so you can just see what exactly the file looks like without any of the GitHub UI overlays. And finally, there's this feature called blame, which is a little bit unfortunately named. I don't want to use it to blame people. But what's really cool about this is you can see exactly who made which change. So when you look at the file and you look at every line of code in that file, you can see when each line of code was last updated and by whom. So in the README, it was all me. However, I believe if I go to styles.css and I look at the history there, if I look at the blame there, you'll see that there was this one line that was updated by somebody who attended one of the shopping workshops for this class, right? And so you can see exactly which line of code was last edited by whom, and you can go and ask them why they did a certain edit, or you can get their help sort of deciphering that code or whatever you may need. Okay, so I'm going to go back to the simple website. As you remember from the Git lesson, Git allows for a nonlinear workflow. So you can have a bunch of versions of a project at the same time. And the way you can see that is by clicking this little element on the left here. And this shows you all the different branches that are available for a particular code base. So for example, there's main, and then there's clean. So this branch is 2 commits behind main. And then there are these 2 other patches here. So there are 4 branches. And you can click on the 4 branches link, and that will take you to a page that will show you all the branches on a particular site and how far ahead, how many commits behind or how many commits ahead of the main branch each one of these branches is. So the clean branch, for example, it's 2 commits behind main, which means that clean was branched off at a certain point and then main continued on, and there were 2 more commits in the main branch. Okay, so next let's talk about pull requests. Pull requests are a way for you to make a change in a branch and then request that that change or that branch be merged back into the main branch. So here there is changed and to or in text. So let's take a look at this pull request. So this branch, the branch that this pull request is coming from is called dmil patch 1. Unfortunately, it's poorly named. You probably want to name your branches a little bit better, like red background or add drop-down box or something sort of more meaningful than that. And you can see that there's a conversation here. Ideally, there would be some description here of what exactly it is that I did. And then you can look at the commits within that branch. So these are not commits that are in the main branch yet. They're all in this separate branch, and it will show you exactly what I did. So I changed programming and data to programming or data for Policymakers. And then there's this files changed button. So while this branch only has one commit, you can have several commits in a branch, and you can see all the files that have changed from the first to the last commit in that branch. Or like, what is the difference between the top of that branch and the top of the master branch? And I'm going to go back to the conversation, and with this pull request, I'm going to say, no, actually, this class is named Programming and Data for Policymakers. I reject this change, and then I'll just say close with comment, and that will make the comment and close that issue. So now if I go to pull request, you'll notice that it's gone. There's only one left. Let's see what this other one is. Changed words on a bullet point. I go to files changed. Someone says speak with experts and coders on the topic. So again, you can see that somebody has made a new branch. They have made a very small change in that branch, and they've suggested that that change be pulled back into the main branch. That's what's known as a pull request. So it's a request to bring one branch, or to merge one branch into another. Okay, so if I want to edit a file, I can either edit it. If I want to edit a file, there is a little feature in GitHub that allows you to do that. So you can click this little pencil on any file. In main.js, for example, I can click this little pencil and edit the file. However, I don't want to edit the file in the main branch. Ideally, I want to create a new branch every time I make an edit. So here, this says, ouch, stop poking me. Let's suppose I wanted to change that text to, hey, you've just clicked the logo, right? What I can do is create a new branch. I'm going to call this branch update logo click text. You want to give it some sort of meaningful name that when somebody scrolls through all the branches, they can see roughly what it is that that branch does. So now you'll notice that I'm inside the update logo click text branch, and it says branch created. Now I can go ahead and make an edit. So here it says, ouch, stop poking me. I'm going to change that to, hey, you just clicked the logo. And I'll say update the text when you click the logo to something sensible. And finally, I'm just going to commit directly to this branch because I've already switched over to it. I don't want to create a new branch. I'm already in my new branch. And I hit commit changes. So now you'll notice that this branch, the update logo click text branch, is one commit ahead of the main branch. There's actually a way to take a look at this, I believe, in the Insights tab. So you don't necessarily need to know about this, but I do want to show you. In the Insights branch, there's a network tab, and that actually shows you the network of all the branches here. And so if you look closely, you'll see that this black one at the top, that's the main branch, and these are all the commits to that main branch. And right here at the end, I created a new branch that was the update logo click text branch, and here is that commit that we just made. Now suppose I want to merge that commit back into the main branch. I might go and make a pull request. I'm going to say new pull request. I'm going to request that update logo click text is merged into the main branch. There's a preview of the change, and I will say create pull request. And here I might want to leave a note. I think it is a bit tacky for the image to say ouch. I've changed it to just an acknowledgement that the logo was clicked. Misspelled acknowledgement, of course. And I will hit create pull request. So this is a good place for you to just interact with other members of your team and explain what it is that you're doing. I might add a logo that's like bug or documentation or whatever it may be. I'm just going to go ahead and create this pull request right now. Okay, so you'll see this is the pull request. And now I can go ahead and merge that pull request because I'm also an admin on this repository. And now if I go to the simple website, you'll notice that in the main branch, the most recent commit is the one that we just made, update the text when you click the logo to something sensible. This is a merge commit. We're going to talk about that a little bit later. And if I go back to that network tab in the insights, you'll see that this branch has now been merged back into the main branch, right? And so this is what the structure looks like. It was at one point in its own branch. Now that has been merged into main. A couple more things I want to show you. GitHub also has a really nice drag and drop interface, so you can always just drag files to upload them into GitHub. We're not going to use this much, and again, when you add a file, that's a commit, right? So you would have to explain what file you just added and hit commit changes. I'm going to cancel this. We're not going to use that a ton in this class because we're going to learn a workflow where we actually copy the repository onto our own computers, work on our own computer, and then push it back up. But I wanted you to know that that does exist for simplicity's sake, so you can use it if you wish to. GitHub, as I mentioned, it's also a really great place for collaboration. So you can sort of have multiple people working on a repository. Oftentimes we have teams of 5, 10, 20 people working on the same repository. And it's also a really great place for serving up websites. So you'll notice that this code is stored here. But if I go to settings, it's not by default publishing to a website. You have to go into the settings, go down to GitHub Pages, and say, I want from the main branch to publish this as a website. And if you hit save, then it says your site is published at this URL. And when I go there, there it is. So if I were to turn that off, then this site would stop publishing here, and it would just be a repository of source code without an actual website being published off of it. Okay, I'm going to come back to the module here for a second because I want to show you a couple of other uses of GitHub outside of the programming and data context. While it has primarily been developed and has primarily been used as a tool to store code and data, code in particular, it also has a lot of really powerful features that can and are being used in other types of work as well. Git is a great system for auditing changes to any kind of file, not just a coding file. It works better with text-based formats than it does with binary formats. We can talk about that a little bit later in class when we get to data formats, but any file that is in a simple, flat text-based format, Git is really good at identifying differences in. You can also collaboratively use it to edit a text document, for example. We saw that with the READMEs. You can also edit stories, text documents, anything else that's in a text format. Here's an example use case of the US Web Design Standard. So the US government's web design standards are hosted in a GitHub repository. These are available at designsystem.digital.gov. So you can see that this is a website where the GSA, the General Services Administration, has hosted a guide to how government websites should be designed. And the members of the public can come to this issues tab, for example, and they can actually interact with the developers of these web design standards. So let's suppose that I'm colorblind and the government has not yet accounted for colorblind colors, which I'm sure they have, but let's assume that they haven't. I could come in here and create a new issue and say, I have a feature request, and that feature request is support for colorblind colors, and I could describe what exactly I wanted, or I could report a bug if I noticed a bug in their site. So this is a really great way for people within an organization, or even outside of an organization, or even members of the general public, depending on how publicly accessible you make your repository, to discuss problems, issues, requests, and to really interact with your programming team. And as we'll learn as we go through this class, that user interaction is actually really crucial to building good software. It's also been used for an open comment period for a policy. So for example, I believe this was during the Obama administration, the White House published a source code policy, and they stored the open comments for that source code policy on GitHub. So you could just go in and write a comment, or you could email them a comment which could get funneled into GitHub issues. However, you could also just create a new issue, and the nice thing about it is that you could point to particular lines in the source code policy that you're talking about or that you want changed. This is somebody that's just saying the policy PDF is missing, and they can respond to that and say, hey, it's still available in the archive, and this person closed the issue and resolved it. However, you'll notice that you can also submit pull requests. And so this is someone that has gone through the White House source code policy and suggested this change where they changed anything from whitehouse.gov to the Obama White House archives. And somebody on the other end could look at this and say, hey, that's actually a good idea. Why don't I incorporate it into the source code policy? And back when the source code policy was being made, you could actually recommend changes to the policy itself, and the team could look at it and decide whether or not that was a good idea. So it's a really deep way for you as a government official who's working on a project to interact with people, at least people who are familiar with the interface. And of course, you can make it accessible via other formats too, like email or what have you. GitHub has also been used for drafting and collaborating on legal documents. So this is an example of Twitter's Innovators Patent Agreement, and you'll see that it is a legal document. I admit I'm not a legal scholar of any kind, so I don't always know what goes into making a legal document. However, you can see that this was last updated 12 years ago in 2013, and you can see every single change that was made to this particular document. So for example, this commit is grammar, subject, verb, agreement, and somebody has just updated this one thing. Whoever this is may be an employee of Twitter, they may not be, it may be suggested and then somebody on the inside accepted it, I'm not sure. This, you'll see update innovators, let's see, added explicit third-party beneficiary clause, and so you can see they changed the version number and then added this additional clause, and you could have a discussion here. There are some pull requests that seem like they're still open. This person named Ghost has apparently added a couple of words here and there in the hopes of making it more clear. That was in 2016, but does not seem to have gotten a response just yet, other than what seems like an automated response. Okay. Yeah, and you can see all of the different issues that other people have put in this innovator patent agreement. Okay. Here's an example of the use of GitHub for design. So let's suppose you have an image that you're designing. You can view those images in GitHub. GitHub also has a really nice feature where it allows you to see the differences between two different points, save points within an image. So for example, let's say you choose two commits. You can sort of move this slider around and see the difference between commit 1 and commit 2. In this case, it seems like one of them has a white background and one of them, the background has been removed. So let's suppose you're working on this image and you make a few different changes. So in one commit, you add a monocle to this octopus. In another commit, you add a glass. And in a third commit, you add the top hat. And in a fourth commit, let's say you change the color of the little stand that this person is on. Using the Diff feature in GitHub or in Git, you can actually see the differences between those 2 points in time. And so you can just move this slider to see the first commit and the last commit and all the things that have changed in between. You can also imagine a version where there are 4 different branches, one with a sophisticated octopus, one with a happy octopus, one with a sad octopus, and you can kind of show people all those versions and decide which one you want to be sort of the main version. And so you can create different branches and operate with, and sort of experiment with some freedom when it comes to design. A couple more things. I definitely misspelled journalism there. There's an open journalism showcase. I'm proud to say that the 538 data repository that I maintain is the first one in GitHub's open journalism showcase. But you'll see here the New York Times has one. I believe Data Desk is LA Times, if I'm not wrong. Yes, that's the LA Times Data Desk. A couple of other news organizations, a lot of them actually have GitHubs where they host either data behind some of their stories like we do, or code for tools that they use for reporting, where other reporters in other organizations can also use and improve upon those tools. So it really creates a nice community of people that are sharing infrastructure for a particular cause. It's also a really great way for us to interact with the public. I would encourage you to check out government.github.com. This is GitHub for government and their sort of showcase of what governments all over the world are using GitHub for. You'll see it says more than just code, open source, open data, open government. I would encourage you to sort of scroll around this and look at it and see what governments all over the world are using open source technology and GitHub in specific for. And here's the GitHub for Government community page. And so you can see all these different governments that are using GitHub for a variety of purposes. And these are agencies at countries all over the world. So as you can see, Git and GitHub are really powerful tools. And while they're primarily used for source code, there are also a lot of other uses for these tools that you may be able to find in your day-to-day work. And if you don't end up using these tools, maybe some of the lessons from using these tools will carry over to whatever work it is that you're doing.